Welcome to the deep dive. Today we're looking at something truly foundational for, well, almost all modern technology, the Leyden jar.
Yes, the very first device designed to actually accumulate and uh, store electrical charge. It really is the grandparent of the modern capacitor.
That little component tucked away in, your phone, your computer, everything.
Exactly. And its discovery was, well, quite dramatic. It wasn't just one inventor either. It popped up almost at the same time in two different places.
Right. There was the German cleric Ewald Georg von Kleist in late 1745.
And then just a few months later, January 1746, the Dutch scientist Peter van Muschenbroek, working in Leiden, which is where the name comes from.
And Van Muschenbroek's own account of his first encounter is just incredible. It really captures the shock, literally, of this new force.
Oh, absolutely. He called it a new but terrible experiment. He describes a shock so intense. Well, he thought that was it for him.
He wrote his body quivered just like someone hit by lightning. I mean, imagine thinking you were done for just from touching a glass jar.
It's wild to think the early setup involved, holding the jar while water inside was charged. Your own hand was part of the circuit.
So, okay, beyond the sheer terror, how did this thing actually work? It's a jar. Glass is an insulator, right? How does it store energy?
That was the initial confusion. People thought the charge must be in the water or, later, the metal foil they used. But the jar itself is key.
How so?
The glass acts as the insulator, the barrier separating two conductive surfaces, one inside, one outside. Think of it like, well, the foils hold opposite charges, positive and negative.
Okay.
And they're attracted to each other, but they can't cross the glass barrier. So the energy gets stored in that tension, polarized across the glass.
And this is where Benjamin Franklin steps in with a really crucial insight, wasn't it?
Exactly. Franklin did experiments that showed the charge wasn't actually in the conductive water or foil. It was stored in the glass.
Ah, so the insulating material itself, the dielectric, as we'd call it now.
Precisely. That understanding led him to call the device a condenser, because it condensed the electrical charge onto the surfaces of the glass. That term stuck for a long time.
And Franklin, he knew how dangerous this could be. He wasn't just playing around.
No, he definitely respected the power. He warned that discharging even one jar, especially if it was large or well-charged, was sufficient to knock a stout man down.
Doesn't mince words.
Not at all. But, despite the danger, or maybe because of it, the Leyden jar became a huge sensation.
This is where Jean-Antoine Nollet comes in.
Yes, the French physicist.
Yeah.
He's the one who really popularized it, gave it the Leyden jar name, and used it for these spectacular public demonstrations.
Spectacular is maybe an understatement. The story about the monks always gets me.
Right. He supposedly had 700 monks hold hands in a long line.
A mile-long line, wasn't it?
Something like that, yes. And when he connected the jar to the ends of the line, poof, they all apparently jumped simultaneously into the air. Can you imagine seeing that?
It's pure theater. But it showed the potential power.
Which brings us back to Franklin again, right? He saw a practical application beyond parlor tricks.
A very practical one. He realized if one jar stored some energy, multiple jars connected together could store much more. So around 1748, he linked several jars in parallel.
Increasing the capacity.
Exactly. And he needed a name for this linked array of jars, this collection of electrical storage units. He called it an electrical battery.
The first battery. Not like our chemical batteries today,
Yeah.
but the first time that term was used for storing electrical power. Amazing.
It really is. And that concept, storing and then discharging energy, paved the way for everything from early kind of crude electrotherapy experiments
Right.
to the fundamental principles behind the capacitors that are essential in, well, virtually all modern electronics.
So it really was, as some described it, like going from a firecracker to a hand grenade in terms of controlling electricity. A huge leap.
A monumental leap. It gave experimenters a way to actually hold and use significant amounts of electrical charge for the first time. An incredible device born from accidental shocks and glass jars. It really laid the groundwork. But thinking about those early days, it leaves you with a fascinating question, doesn't it?
It does. They had this powerful tool, this stored lightning in a bottle, but they were still grappling with the fundamentals.
Like how? How does this invisible force even work? How does it act across a distance through glass?
Exactly. We rely on electricity constantly now. It powers our entire world. Yet those core questions the pioneers faced, what is the fundamental nature of this force we harness? That mystery, that deeper question, is still something science explores today, something to think about next time you plug something in.